pre-calculus students. I hope you guys are staying warm and safe today. Today we're going to continue in chapter 3, part 1. So you guys can go and grab your notes right quick. You can either take these notes on your own paper or you can print off the notes that I have posted online for you to use as we go through today's lesson. So today we're going to talk a lot about functions, and that's what your bell work is today, dealing with some aspects of what a function is and some aspects of graphing. Our question states, state the domain and the range of each function below. So I would pause the video here, see if you can look at those two graphs and analyze what their domain and range are going to be. Then you can play the video back and check your work. Let's go ahead and check your work right quick. So recall, domain is the x value and range is the set of y values of each graph, of each ordered pair. So let's go ahead and look at the first one. The domain are all of the x values that the graph touches. And I'm going to list these out as a set. So I'm going to use set bars because they're not connected dots. It's just dots that are in a line. And our domain is -3 right here for the x value. This dot is at -2. This dot has an x value of -1. This dot is at 0. This dot is at 1. And this dot up here is at 2. Those are all of the x values that graph touches. Now let's do the range. The range, remember, are the y values. So your y values are -3, -1, 1, 3, 5, and 7. Those are just listing the y values of that ordered pair. Now let's do the second example. The domain, again, the set of x values is -3 at that point, -1 at the next one, +1 at the next one, 3, 5, and 7. Those are the set of x values. Now let's do the range, which is the set of y values. Looking at those ordered pairs, it's -3, -2, -1, 0, 1, and 2. So that's the domain and range of those two graphs. Today our notes come from chapter 3, section 1, and we're going to learn about something called inverse functions. Before we learn about what an inverse function is, I'd like you to reflect on your bell work today. Look back at your bell work that we just did and think about what relationship you noticed between the domain, the x values, and the range, the y values, on the graphs that we just did on your bell work. Something that I wanted you to notice on your bell work, and hopefully you saw, is that the domain, the set of x values, and the range, the set of y values, were flipped or inverted on both functions. So on the first function, the red one, the domain became the range on the second function, and the range on the first function became the domain on the second function. So they were just inverted. And we can see that just looking at our ordered pairs. For instance, here's the ordered pair 1, 5 is up here on the red graph, 1, 5. If we invert that, then we have an ordered pair of 5, 1, and that's right here on the blue graph. When we take our x and our y value and flip them, that is called an inverse relationship. Graphically, what that means is that we took the original function and reflected it over the line that's down the middle of the inverted line and the original line, and that's the line y equals x. So anytime you are asked to find an inverse, like you are on your homework today, just take the x and y values and flip them to graph the inverted function. So inverse, as we just saw, means to flip the x and the y values of your function. Since we're talking about functions, let's talk about what it means to be a function. The graph at the right here, y equals x squared, is a parabola because it makes this U shape. And a graph is a function if no x values repeat. That's what it means to be a function. You also learn something that's very useful whenever it comes to graphing functions. The function must pass the vertical line test. That's what makes it a function as well. So as you look at the graph on the right side, if I draw vertical lines through it, it does pass the vertical line test because it only crossed once through each vertical line, which means yes, it's a function because it passes the vertical line test. Let's try the next one. Is the inverse a function? So how I know if the inverse is a function is we want to find, does the graph that they gave to us pass what's known as the horizontal line test? That's what we want to know. Does the graph pass the horizontal line test? If I start drawing horizontal lines through the graph, you'll notice it crosses once there and once there. Since it crosses more than one time, this fails the test, so the inverse is not a function. So the inverse is not a function because the graph fails the horizontal line test. That's what that abbreviation stands for, horizontal line test. Your last definition for today is the function one-to-one? So a function is one-to-one if for every y value there exists only one x, and basically vice versa. For every x value, there exists only one y value. That's your definition for the graph to be one-to-one. In short terms, it just means that the graph passes the vertical line test and the horizontal line test. So if the graph must pass both tests in order for the function to be one-to-one. It has to pass both the vertical and the horizontal line test. As you can see from our graph, it is a function, so it passed the vertical line test, but it did not pass the horizontal line test, which tells us that no, the graph is not one-to-one because it failed the horizontal line test. And I'm fine if you want to abbreviate that, HLT. On our next example, we're going to analyze a function just like we were doing before. Before continuing though, I'd like you to go type in this equation into your graphing calculator or Desmos. Just go graph it please so you can see what the graph looks like. And then we can analyze the pieces. Our first question states, is this graph a function? Well, as you look to the right, I graphed it for you. Remember, we're asking ourselves, does this pass the vertical line test in order for it to be a function? So as I draw vertical lines through the graph, you can see it crosses once each time, which means yes, the graph is a function because it passes the vertical line test. Now, is the inverse a function? Remember, in order for the inverse to be a function, the graph has to pass the horizontal line test. So as we look at our graph, and I draw horizontal lines through the function, like this, does it cross once or twice? Crosses just once. So yes, the inverse is a function because the graph passes the horizontal line test. Our last question, is the function one-to-one? Remember, for a function to be one-to-one, it has to pass both of those tests, both the vertical line test and the horizontal line test. Since our function passed the vertical line test and the horizontal line test, we can conclude that yes, the graph is one-to-one because it passes both the vertical line test and the horizontal line test. Besides graphing inverse functions, we can also look at inverse equations. So how you find the inverse of an equation when you're not given the graph is the first step is to flip x and the y value, where they're located at in the equation, and then we're going to solve for y to find the inverse function. Let's look at example A. We have y equals 6x plus 2. So the first step we're going to do is flip where x and y are located at. Now I'm going to solve for y just using our algebraic skills. First, subtract 2 to both sides, so that x minus 2 equals 6y. And 2 minus 2 is 0, so that goes away. Now to get the y by itself, I'm going to divide both sides by 6. So that x minus 2 over 6 equals y. Now that y is by itself, this is our inverse function. X minus 2 over 6 equals, your notation to denote the difference between the function and the inverse looks like this, f inverse of x. Remember that -1? We learned about inverse trig functions that had that little -1 power. That means that it's an inverse function. And that's our answer. X minus 2 over 6 equals f inverse of x. Let's try our second example. Again, I'm going to flip x and y and solve for y. Since we don't see a y here, this function notation tells us that g of x is really y. So you can replace that with a y if that makes you feel better. Over 4. Now I'm going to flip x and y. Just flip where they're located at. And now I'm going to solve for y. First step is to multiply 4 on both sides to get rid of the fraction. 4x equals -y plus 3. Now I'm going to subtract 3 to both sides, so that 4x minus 3 equals -y. And the last step to get y by itself, it's a -y, so I'm going to divide everything by -1 to make that a positive y. So we end up with -4x plus 3 equals y. There's our inverse function, so I'm going to use that inverse notation. Equals g inverse of x. There's our inverse function. -4x plus 3 equals g inverse of x. Let's try another example. Our question states find the inverse again. So we're going to flip x and y and solve for y. Remember, m of x is function notation for y. So far we have y equals the cube root of x minus 9. I'm going to flip where x and y are located at. And now we're just going to solve for y. You'll notice that y is inside of the cube root, and I can't get to it yet. So to get rid of the cube root, we're actually going to cube both sides of the equation. So x cubed equals y minus 9. Remember, just like square and square roots undo each other, cubes and cube roots undo each other, so we're left with just the y minus 9. Now to get y by itself, I'm going to add 9 to both sides. So that x cubed plus 9 equals y. Now that we've got y by itself, that means we're done and we can set up the inverse equation. X cubed plus 9 equals m inverse of x. And that is the inverse function. Let's try one more example. I would pause the video here, see how you do just trying to find the inverse on your own. Then you can play the video back and check your work. Let's go ahead and check it though. Remember, p of x is function notation for y. So we have y equals x minus 4 squared minus 6. Now I'm going to flip where x and y are located at and do some algebra to solve for y. First, let's move the 6 to the other side so we can get that squared by itself. So x plus 6 equals y minus 4 squared. That's still on the right side. Now to get inside to this y value, because it's inside parentheses, we're going to have to get rid of the parentheses first. So to undo something that's squared, I'm going to take the square root of both sides. So we have the square root of x plus 6 equals y minus 4. Because we took the square root, it is very important that you remember you took a square root, so we need a plus or minus sign on the outside of that square root symbol. Now we can keep solving. I'm going to add 4 to both sides to get the y by itself. So we have 4 plus or minus the square root of x plus 6 equals y. Now that y is by itself, this is our inverse function. 4 plus or minus the square root of x plus 6 equals p inverse of x. So that's how you find the inverse of an equation.